Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your genes. I'm Ian Woolf. On this International Women's Day edition, I speak with Naomi Koh Belic about stem cell models of multiple sclerosis. But first up, here's the news about the science of women in work and science and drone deliveries. Why are so few women in science? Researchers from the Leeds Beckett University and the University of Missouri found that around the world, more girls had the capability to study science, technology, engineering and maths than had enrolled in those subjects. Surprisingly, they found that nations with the least legally protected rights for women had the highest enrollment of women in science. In nations where women had a choice, they chose science less often, indicating there's something less appealing about science as a career for women. The researchers examined the academic achievement of almost 475,000 high school students across 67 nations or economic regions. They found that girls and boys had the same levels of science literacy, but while boys tended to have science and maths as their strength over reading, girls tended to do well at science, maths, and reading. Even girls who outperformed boys in science skills tended to perform even better in their reading skills, which may allow them to choose from a wider spectrum of careers. The researchers used the United Nations Educational, Scientific and Cultural Organization, UNESCO, report on national statistics of education to find the number of women STEM graduates in natural sciences, mathematics, statistics, information and communication technologies, engineering, manufacturing, and construction. They found women STEM graduates ranged from 12.4% in Macau to 40.7% in Algeria. The median was 25.4%. The World Economic Forum's Global Gender Gap Report measured the degree to which girls and women fall behind boys and men on 14 key indicators of things like earnings, tertiary enrolment ratios, life expectancy, and seats in Parliament. The United Nations Development Programme measured overall life satisfaction as one of its indicators. The researchers look for information on individual students' relative strengths in different subjects, as this usually leads the career advice they're given. The data showed that on average across nations, 24% of girls had science as their stronger subject, 25% of girls had mathematics as their strength, and 51% had reading as their greatest strength. The corresponding values for boys were 38% science, 42% mathematics, and 20% reading as their greatest strength. The difference between the percentage of girls with a strength in science or mathematics was always equally large or larger than the percentage of women graduating in STEM subjects. Women in countries with more gender equality who chose to study science tended to quit more often than in countries with less gender equality. So girls test as well as boys for science skills and interest in science at high school, but a much lower number choose a scientific career, and an even lower number stay there. The researchers think that women in countries with higher gender inequality are simply seeking the clearest possible path to financial freedom, and it happens to go through a STEM career. Whereas when women have a wider choice, they choose other careers. The paper was titled The Gender Equality Paradox in Science, Technology, Engineering and Mathematics Education, and was published in the journal Psychological Science. Confidence is not enough. Women frequently get paid less than men for the same job in many workplaces and get promoted much less often. Women are usually told that the problem lies with them not being as confident and assertive as the men. Economics research by Dr. Leonora Rees of the Royal Melbourne Institute of Technology RMIT shows that while men who are more confident and assertive are rewarded with 3.3% more job promotions, women who are more confident and assertive barely get rewarded at all. Among Australia's 12 million employees, 150,000 more men than women are promoted each year. The RMIT study looked at 7,500 employees across Australia using the Household Income and Labour Dynamics in Australia (HILDA) survey. The study measured confidence using a psychological survey that asked about hope for success and fear of failure. Workers with higher confidence or hope for success were generally more likely to be promoted in the following year. On average, men have a higher hope for success, while women have a higher fear of failure. The results show that when you're comparing a man and a woman in the uppermost end of the confidence scale, your chances of promotion rise from 8% to 14% if you're a highly confident man, but remain at around 7 to 8% if you're a highly confident woman. Being confident just doesn't make much difference for women. This is consistent with other research from Harvard University and Carnegie Mellon University, showing women are punished for demonstrating ambition, confidence, assertiveness, and leadership qualities in the workplace. Women acting like men don't get rewarded, while being blamed for not being more like men. Fixing the women doesn't fix the gender promotion and pay problem in the workplace. The paper for that study was titled Social Incentives for Gender Differences in the Propensity to Initiate Negotiations. Sometimes it does hurt to ask, and was published in the journal Organisational Behaviour and Human Decision Processes. The real problem seems to be bias against women in the workplace. The findings from RMIT were presented recently at the inaugural Australian Gender Economics Workshop hosted by the newly formed Women in Economics Network Australia. And now for something completely different. Project Wing delivers. Australia's Civil Aviation Safety Authority is working with Google's parent company Alphabet to find out the risks involved with using drones to deliver packages. Project Wing is delivering one brand of Mexican food and supplies from a discount pharmacy in Royalla to people living remotely on farms in Googong, along the border between New South Wales and the Australian Capital Territory. Royalla is 35 kilometres outside of Canberra. The Civil Aviation Safety Authority has established an internal branch of 20 people to deal with matters involving remotely piloted aerial vehicles. In May 2017, this branch released the Can I Fly Here app that shows you where you can and cannot legally fly your drone. Due to some weirdness in programming, I've found that the app only works if you have Wi-Fi turned on, even when you're in a park. Australian companies like Flirty tried in 2013 to organise trials of drone deliveries to remote areas, but the Civil Aviation Safety Authority wouldn't work with them. Flirty were forced to relocate to the USA. Did Alphabet have more credibility than an Australian startup? Or was CASA just not ready until 2014, when Project Wing first started testing drones in Australia? Project Wing signed up 150 people living on remote farms within a 20-kilometre diameter of the drone base. Remote farms are easier for regulators because there are fewer people, buildings, and roads to fly over. The regulations say that you can't fly over buildings or properties without permission from the owners, and normally you can't fly within 30 metres of people or roads. This is in case the drone falls out of the sky and hits someone. Flying over big fields and paddocks makes it easier to find an open space to deliver. People in these areas need to drive a 40-minute round trip to their nearest shops and say they would rather get a delivery in minutes by drone that they've ordered by an app. These aren't your hobby quadcopters, but fixed-wing aircraft with 2 vertical and 12 horizontal rotors that can take off vertically and then rotate to fly like a plane at 120 kilometres an hour. They make deliveries up to 10 kilometres away within 10 minutes. They hover 5 metres above the ground to lower a package for delivery before turning around to return to base. The drones can carry a package of up to 1 kilogram. Project Wing's unmanned traffic management platform lets the project team plan a flight route. Sensors on the drones identify obstacles that might appear during a flight or delivery. The drones fly autonomously, with a remote pilot just watching, but ready to take over if something goes wrong. Alphabet will be given exemptions from regulations against one pilot operating several remotely piloted aerial vehicles simultaneously for future trials. For now, it's one pilot per drone. Project Wing have partnered with Unmanned Systems Australia, a Brisbane-based company, and are using their remote operator certificate to conduct the testing. The remote operator certificate allows the company to fly drones within 15 metres of people that have given consent to be included in the test. Farmers near the drone testing corridor say they're worried the noise will scare their animals into bolting, and they're afraid of losing privacy to delivery drones. Farmers taking part in the trial love the idea of getting hot food in 10 minutes and like being able to get medicine straight to the door when they're sick. After 6 months of drone deliveries in rural Gugong, Alphabet are now expanding the test to the suburbs of Tuggeranong, where it will have to work out how to fly over backyards instead of paddocks. People living in Tuggeranong can sign up to be part of the trial at x.company/wing/Australia. When the Civil Aviation and Safety Authority open up air corridors for commercial drone delivery, I hope they remember to consult with hobbyists, to factor in places where hobbyists and kids can legally fly their drones as well. If you don't provide a way for an ever-growing number of people to fly their hobby and toy drones legally, then they'll just fly illegally. If parks can set aside areas where people can throw hard balls at high speed that could kill and injure if they hit someone, then why not also provide safe flying areas? You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. How do you study multiple sclerosis? Naomi Koh Belic is a stem cell researcher from the University of Technology, Sydney. She studies the difference between disease cells and healthy cells using stem cells. Naomi came to my attention as an alumni of FameLab. I began by asking her, as a stem cell researcher, which illnesses does she study?
So I have a particular interest in multiple sclerosis, so I try and investigate developing a better understanding of that disease.
And what sparked your interest in multiple sclerosis?
I've always had this really big interest in anything to really do with the brain. I think there's just so much about it that we don't understand yet, so it's really exciting to be on the frontier of that research. And when it comes to diseases of the brain, so neurodegenerative diseases, there are so many different kinds. But multiple sclerosis really sparked my interest because it's a particularly complex disease.
And what is it that's going wrong with multiple sclerosis?
That's the whole thing. We know some things about it, but there's so much we still don't know. And that makes sense because it's really, really hard to study any brain disease because it's so hard to get pieces of brain tissue from patients. And even then, it's really hard to accurately model a disease when we don't know that much about it. So the idea of my research is to try and model the disease in a different way.
And so how are you modelling it? How do you use stem cells to model a disease in the human brain?
Yeah, so it's really exciting. I actually have volunteers, so patients with multiple sclerosis. They go and get some free liposuction, so I end up with these tubes of seriously warm, thick, gooey fat. It looks like a hunky cheese pasta sauce. It's not nice stuff. I isolate the stem cells out of it and then I grow it in a dish. So I like to call what I'm doing a disease in a dish, and it's a good way of explaining it. But it does sound a little bit funny because I think people imagine kind of like a bowl full of fat cells. But that's kind of what it is.
And so these fat cells, you're looking to get stem cells out of the fat cells?
Yeah, so I get stem cells out of the fat. And the cool thing about stem cells is they can turn into pretty much any kind of cell if you give them the right environment. So I isolate stem cells directly from your belly fat and I turn them into neurons, so the cells that are found in your brain. And I use this to model multiple sclerosis in my little disease in a dish.
And so why fat cells and not something like skin cells that are easier to get?
Yeah, so there's all different kinds of stem cells that you can get. Broadly speaking, there's multipotent and then pluripotent stem cells, and that potency just refers to their ability to turn into different kind of cells. When we talk about adult stem cells, the most common sources you probably know of are bone marrow and adipose, so those being your nice belly fat stem cells. And I choose to work with stem cells from your fat instead, just because they're much easier to get to than, say, your bone marrow stem cells.
How do you separate stem cells from regular fat cells?
Yeah, so it's a relatively complex process, but in short, we pretty much want to break it all up and we use an enzyme called collagenase, and that goes through and tears up all my tissue, and then I just separate the stem cells out.
And once you've got the stem cells, how do you make them into brain cells?
So I'll give you a little bit of background on how the cells grow so I can explain it a little bit more. So once you get the stem cells out of your fat, they're kind of like the shape of your hand, right? They're quite square and blocky, and they stick to the plastic of the dishes that I grow them in. And once they're stuck there, it's really easy to feed them. So I just put liquid on. So imagine you're on a liquid diet. It's almost like a Powerade mixture. It's red in colour, and it's got all these nutrients that feed the cells. And whenever I want to feed them again, I just pour it off and pour new stuff on. The cool thing about turning stem cells into neurons is that it's a really simple process. All you have to do is change the environment that they're in. So I pour off the stuff that they're currently being fed and put on this special mixture that has all these different kinds of nutrients that literally push them down a pathway. Visually, if you imagine them the same thing as your square kind of shape of your hand, they start to retract. So they start to pull up and they get these long, thin extensions everywhere. And that's how you can tell that they're going down a neuronal pathway.
And so you end up with little balls of neurons?
They're still all like stuck down to the plastic a bit, but it's really, really interesting and they're really, really beautiful. And the cool thing is when you compare my multiple sclerosis patients to my healthy patient samples, you get to see a difference, both visually and then with what I look at, which is proteomics. So I study the proteins inside of cells.
So the proteins are different?
Yeah. So it's really, really cool. So I think studying proteins is amazing. I mean, I might be a little bit biased. I obviously love proteomics. But to me, it's kind of like you rip open your cells and you take a snapshot. And what you can see is exactly what's happening inside of that cell at that moment in time. So it's really comprehensive. And if I compare my healthy patients to my multiple sclerosis patients, and you look at what's different, that gives you more information on multiple sclerosis itself.
This information you're gathering, the proteins that are different, can this lead to treatments or just better insights?
To be honest, both. So the research I'm doing is very basic primary research. So the stuff I'm doing isn't directly going to impact a patient tomorrow, but it's really exciting because we don't really understand the proteins inside of stem cells. So you think of it right now, let's say there's thousands of proteins inside of this cell, we only really understand just a small handful of those. So what I'm trying to do is actually go through and characterize every single protein that's in there, look at how those proteins interact with each other, and then create this really great, comprehensive, I guess almost like a library, like an instruction manual on how all these proteins work together. And the cool thing is because I'm working in this really early stage of research, everything I'm doing can be used by future researchers, so different scientists, different clinicians, and there's so much potential.
So you look at the proteomics of the diseased stem cells and the healthy stem cells, and then what's the next step after that?
So for me, I'm really, the initial stuff I do is just characterizing and understanding all those proteins. Now, when I start to figure out the proteins that are different between the two, so the proteins that make multiple sclerosis that are really interesting with that particular disease, I can start focusing on particular proteins. So let's say, theoretically, there's one protein. There's obviously going to be a lot more, but just for simple explanation, there's one protein that's really important, that's really different between the two. I can then use immunofluorescence microscopy, so that sounds really complex. But basically, when you look down a microscope, that particular protein, we can get it to light up. So I can actually see where that protein is inside of a cell and really start to understand the role that it plays. So more exciting research like that.
And if people want to get into your line of research, what should they do if they're high school kids? What should they study to get into your area?
I mean, to be completely honest with you, you don't have to come from a scientific background to do science. I think, especially when you're in school, it's always hard to decide what you love, but when you find it, just keep on chasing it. I'm very fortunate I happened to stumble into science when I was in school and then stumbled into a science degree and stumbled into a PhD, and I'm still here now doing science, but you don't have to follow a direct pathway. You know, you could be doing arts or history or whatever really, I guess whatever you're really passionate about. And if you start to have that passion in science, just start pursuing it. Take up a few subjects. If you want to do it in uni, you can go and do it. It's really, really open to everyone.
And you've been presenting your research on the stage.
Yeah, so that's really exciting for me. I mean, I personally was not a big communicator. I used to always shake heaps. I'd always have to have a script. And it's not something I was confident with. But I had the opportunity to enter FameLab. So it's a competition throughout Australia, and then it's also in 30 countries overseas. So it's a really, really big competition. I kind of decided I'd enter it anyway. And the best thing about it is they gave me really, really good training. So they make you confident and comfortable with being up on the stage. And I got to go and chat about my science to an audience there. I was lucky enough to make it to nationals. And I was really lucky enough to see one of my close friends make it all the way to the international finals. That's really, really fun.
That wasn't your last effort in presenting your science to the world, or in fact, performing science in a way.
Yeah, so it really did open the door for me, and it's not something I expected, but since starting with FameLab, I've had the opportunity to be a biology expert on all 10 episodes of Dr. Carl's Outrageous Acts of Science, and I idolized Dr. Carl, so that was really, really exciting. And Discovery Channel is just a really fun place to be at. And then I also had the opportunity, somehow, to host my own 5 episodes of ABC Sciencey. So it's a little online series that just breaks down some really interesting science questions. And one of the episodes is focused on what your breath says about you, which is really great because I had the opportunity to interview Nushin, who also did FameLab with me.
Terrific. And Nushin is waiting patiently while I talk to you. And she'll be in the next interview. Where do people go to listen or watch to the episodes that you've produced?
Oh, my sciencey stuff?
Yes.
So that's all on ABC iView, and it's also on ABC Catalyst YouTube channel. So it's little videos everywhere. It's a good online series. It's super accessible. They're really short videos, so it's just a few minutes of your time, and they become really addictive. You start watching one, and then you realise you've spent half your day watching a bunch of them.
Well, Naomi, thank you very much.
Thank you for having me here.
That was Naomi Koh Belic from the University of Technology, Sydney, building stem cell models of multiple sclerosis and communicating science. I'll link to her videos on the Diffusion episode page, and Naomi will return to Diffusion soon to talk more about her experiences with science communication.
Women in general are not as strong as men, but with the right equipment adjusted to their capabilities, they can do just about the same work as men. Their employment, therefore, requires all the health and safety precautions necessary for men, plus some extra measures. Who are these women? Where did they come from? They worked in offices. They liked fun and music and peace. When we first went to work, we were told what was expected of us in the way of good health habits and safe practices. We were told that wearing proper, sensible clothing was a very important item in our new work. Long hair can cause an accident if it falls across the face and eyes and interferes with seeing your work. When working at top speed, as we all are, we can't wear high-heeled shoes. They catch easily, ankles turn, and the effort of balancing ourselves tires us quickly. Dressing sensibly like this, from shoes with wide, low heels to proper headdress, an attractive turban, will give us protection where needed and help us work efficiently and safely. And now another important safety measure. Straighten up. We wouldn't be women if we weren't concerned about our figures. An extra pound here or there can sometimes cause great concern and mental anguish. Relax. Shift your position on your chair frequently. An injury, however trifling it may seem, must be reported at once. Infection and untold suffering may result from a harmless appearing scratch, so let some competent person decide how serious it is. Who are these women? We are these women.
And that's all from us this week on Diffusion. Would you like to hear your voice on radio? Record a voice memo on your phone or use the voicemail tab on the website. We need more people contributing stories to Diffusion. Send your contributions, opinions, helpful suggestions, and donations to science@diffusionradio.com. That's science@diffusionradio.com. And please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate us on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Join my patrons at patreon.com/diffusionradio and support the show so that I can make more episodes. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. Sound check and fact checking by Charles Willock. I produce Diffusion, which is broadcast around Australia to 27 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2MVR in Nambucca Valley, 3MBR in the Mallee Border districts of Victoria and South Australia, and 7LTN City Park Radio in Launceston, Tasmania. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to our podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos from this week's show. If you enjoyed the show, you can explore more than 900 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits: photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.